The electroscope can be used to show the presence of charges, to show charging by induction, or attraction and repulsion of unlike and like charges. So basically, this is the Braun Electroscope, and for this we're going to use a glass rod, a hard rubber rod, and some fur. So the first thing we're going to do is charge up the hard rubber rod with the fur. That'll give it a net negative charge. Okay? And then when I bring it to the top of the electroscope, there's a little top plate on here. What's going to happen is polarization is going to occur. And so that means that the negative charges from the hard rubber rod are going to repel all the negative charges in the electroscope. So they're all going to come down this central bar. Okay, so this central bar is connected directly to the top plate. And actually right here there's a piece of insulation to keep it from going to the metal frame that's around it. So when we refer to the electroscope, we're talking about the plate with the central bar and the needle. And so the needle is also made of metal, and it's directly connected on a pivot right here. So when all these negative charges come as a result of polarization, all this metal here from the bar and the needle are all going to repel each other because they're all the same charge, and like charges repel. All right, and then the positive charges from the electroscope are all going to gather on the top plate there because they're attracted to the negative charges in the rod. So we're charging up the hard rubber rod with the fur that gives the hard rubber rod a net negative charge. And when I bring it close to the top, plate of the electroscope, all right, it starts to polarize, right? So all the negative charges in the rod are causing the negative charges in the electroscope to come down the central bar and also into the needle, whereas the positive charges are attracted to the hard rubber rod with its negative charge. Okay, when I bring it away, there's no polarization. So I can actually charge the electroscope through induction if I bring the rod nearby and then touch the plate. Okay, bring my hand away. Now the rod is negatively charged. The electroscope is positively charged, and all those positive charges are trying to come to the top and attract to the rod, right? So the needle is in its original position. When I bring the rod away, all right, because the electroscope, all right, was induced with a positive charge, it now has a positive charge throughout the whole electroscope, and so it's spreading out everywhere, and those positive charges are all repelling each other. Now, if I were to take the glass rod and rub it with the fur, that'll charge the glass rod positively. And so if I bring it near the positively charged electroscope, all right, the needle moves even further because now I have more positive charge entering the system, and so the positive charges from the glass rod and the electroscope want to repel each other.